Welcome to today's webinar. We are going to be covering a hot topic, large constellation analysis. We already did a couple videos about the large constellations. People call them different things. Sometimes they call them mega constellations. Austin reminded me that that's not what the term is actually, because in this community, mega has a very specific meaning, 1 times 10 to the 6th. And there's a new term that I haven't heard before. It's actually P-LEO, for proliferated LEO. There's another term for these very large constellations, thousands of satellites going up. There's 57,000 planned satellites over the next decade that have applied for licenses to be doing transmitting. And so we did some videos with T.S. Kelso, who runs CelesTrak, to show you how to get the Starlink one. That's probably the most popular of the large constellations, and how you can get the data and you can go out and see the trains. Have you seen any trains yet? Have you gone out and seen them yet?
Not in real life, but I have seen them in STK.
Yeah, it's very cool looking. There's all kinds of pictures of it on the internet. Very, very neat to check out. So what we're going to do today is people have asked us to do a little bit more in-depth look into that. They say, that's great, I can go out and see them, but what else can I figure out? So maybe I do analysis with the satellites and I want to know, what do these large constellations mean to me? And once I get them into STK, like we showed you how to do in a previous video, we wanted to slow it down, go into a little bit more detail, figure out some of the problems you could start to solve. And that's why Austin's here today. And last summer, if you remember Austin's work on the Apollo 11 50th anniversary, Austin very painstakingly recreated very accurately the entire mission from launch to and back. And those videos are really cool. Check them out. That's what our background screen is here. Check those out if you haven't seen them. It's a pretty neat scenario and analysis that you did. But today, Austin, welcome.
All right, thank you very much, Josh.
Thanks for being here and then showing us. So what you're going to go in and you're going to bring up STK and you're going to show us some tools that you wrote and how to take that data that's available and other data that we'll address that in a minute here. Other places where you can get data and load it in and start doing some real work and figuring out what the heck is going on and what does it mean to me as a satellite operator or constellation runner. So let's see what you got.
All right, thanks, Josh. So yeah, what I'm going to be doing today is showing you some Python code I wrote, which helps you go through the process of bringing in these large constellations. So let's go ahead and get started. The code I wrote is in Jupyter Notebook, which is just a way of looking at Python code. So this is all available for download, and all I'm going to do to get this started is just go ahead and execute this Jupyter Notebook.
And we're going to provide the link to download what Austin's showing you in the description below.
Thanks. And as soon as we execute that code, there's a user interface that I built. And what this does is it allows you to, I call this the Constellation Wizard. It allows you to quickly pull in satellites. It allows you to modify them and then start doing analyses.
Pull them into SDK.
Yes, pull them into SDK. So very similar to what you saw on CelesTrak, you can do something very similar in SDK now. So that's great. So I'm also just going to go ahead and pull up SDK. And the first thing I want to do is maybe just give you a quick run through of this Constellation Wizard and sort of its high-level capabilities. So the first thing you'll notice up here, there's an option to create constellations. So if you already have your own constellation in SDK, you can create that and save it for future use. The next thing is you can load in constellations as MTOs. Those are visual objects. And here's the constellation list of constellations available. You'll see that I have CelesTrak in this list. So this script can go and pull from all the updated TLEs from CelesTrak. So anything that's up there right now, you can pull down. And you can
Sorry, real quick, I wanted to talk about the MTO thing because it's not a intuitive term. That stands for the multi-track object. And we have a video or two explaining what that is and what it's used for. But what Austin's going to go and show you is, like you just said, MTOs are largely visualization, whereas what you're going to show is doing some deeper, more meaningful analysis.
Yep, that's exactly right. So the way this constellation worked is it brings them first as an MTO, a multi-track object, purely for visualization purposes. Then after that, we'll do something called deck access, which will allow you to say, hey, I only want these satellites that are currently overhead or in the next hour or so, and bring that subset in for further analysis inside STK.
So what you did is a streamlined interface to easily go get the data right off of CelesTrak and pull it right into SDK. That's very cool.
Yeah, that's exactly right. So all these capabilities we've had before, but really streamline that process and make it easier for you guys was the main goal of this app right here. You'll also see towards the bottom of this list, I've already pre-configured a few satellites, constellations. We have SpaceX, the Starlink, we have OneWeb, and Telesat. So what I'm going to do right now is go ahead and load in the Starlink constellation as an MTO object. This guy's very large. It has thousands of satellites.
So this is the planned constellation.
Yes, this is the planned constellation. So this guy is going to take just a few seconds because there's so many satellites that they plan on launching. And you'll see that. Here we go. So we are located at AGI, and here are all of the Starlink satellites, the planned ones that are loaded in. If you animate this scenario, you'll see those guys moving around. They have a couple different shells here. I'm not going to go into all the specific details, but that's the satellites as planned.
Different shells meaning different orbital altitudes that they operate in.
Mm-hmm. Yep. Different levels. Thanks for the clarification. And if we just want to see the Starlink satellites that are up there right now, I can go pull the most recent CelesTrak Starlink constellation. Maybe give this guy a different color. I'm going to give this guy a magenta and go ahead and load that guy in there as well. And if I go uncheck my large constellation, my SpaceX constellation, you can see these are the orbital planes that are already up there right now.
It's quite a few already. It's a lot.
Yep, they're moving quickly. This thing is supposed to be done in the next few years. So we have a few up there already. Let's go ahead and switch back to the entire constellation. And then now what we're going to do is start to go through and do some sort of analysis. We're going to do a comms analysis between ourself, AGI, and then a geosatellite without the presence of Starlink. And then we're going to go through and do it again, but with the presence of Starlink. So I'm going to start off with that. So I have a geotransmitter. I'm just going to go ahead and open up the properties of that guy, and go to the access panel. And I'm going to compute access from that geo to a ground site we have on the ground here at AGI. This part's a little notional, but the whole idea is to streamline this process so you can apply your specific use cases. So if I go ahead and click compute, I'm going to go look at the carrier to noise ratio for this link. And if I run that, you'll see right now it's just sitting at a flat 10.9 for the carrier to noise ratio in dB. So we'll remember that for later. That's without the presence of any other overhead satellites. Just go ahead and sow the seeds there.
Where nobody else is interfering with you. So
yeah, that might be like today, or maybe a few months ago before none of these satellites launched. That's what carrier to noise ratio we're working with. So one type of things we can do is start considering interference analysis, and I'm going to show you how to set that up. So back over here in the Constellation Wizard, I could have this option to run deck access, and I'm going to do that between not necessarily AGI, but a field of view over AGI. So I already have that pre-configured in SDK, just mostly the satellites that are overhead. And then I'm going to click this Run Deck Access button. And when I do, it says there are 43 satellites with access in our current constellation that's up there, the Starlinks that are actually up there right now. I'm going to switch back to the planned constellation and run this guy.
Now you're doing a comms analysis, but this is just line of sight.
Yes,
so far.
Yes, this is just line of sight. So the idea here is to reduce the number of satellites so you're not pulling in thousands of satellites at a time, then only do a comms analysis on the 100 or so that are relevant. Yep. So I'm going to rerun this deck access with the planned constellation and just for 5 minutes, and we can run it at different time spans. But again, the key idea here is to just reduce the number of satellites. So I don't have thousands of satellites that I have to do large computations for. So now I have 133 satellites that I can see over this 5-minute time span. So what I'm going to do is go ahead and click this Save Deck Access button. And it said, do you want to save this new constellation? I'm going to click No and give it a better name real quick. I'm going to call it SpaceX with access. And then I'm going to go ahead and re-click that button. It says, do you want to save? And I'm going to say yes. So once I have that, it will actually appear in my constellation list. So I can load that constellation back into SpaceX. Load it back.
Praising your features. That was a good feature.
It got me off beat. Load it back into SDK. This guy refreshes anytime there's a new constellation. Nice. So instead of looking at all of SpaceX, now I'm just going to look at the satellites that I can see over that 5-minute time span. So you can animate those guys and see them. Yeah. All right.
So now that's a number that's much more manageable for some quick analysis. But you'll touch on later what to do when you want to do larger number full analysis, right? We'll get into that too.
We can get into that too.
Cool.
Yep. So the idea with this guy is for right now, you have SDK. As long as you have an integration license, and maybe like SAT Pro, or if you're doing comms, you might need comms. As long as you have the relevant modules that you regularly need for SDK and an integration license, you can go ahead and run this and sort of automate your processes. There's also a script version of this, so you can just put this in a big for loop and run different trade studies. So once I have that, I'm going to load these satellites in, and it says using a template. So I'm going to come over here to the right-hand side, and I have a couple satellites already pre-configured in my scenario. I'm just going to go ahead and grab that first Starlink one, and you can see that over here on the left-hand side of my object browser. So each satellite that I'm going to import is going to have this receiver and a transmitter associated with it.
And you got that receiver transmitter information from open source places on the internet?
Yes, I got...
It's not official, but it's published somewhere, and you were able to model that and put it in here.
Yeah, the transmitter information and some of the orbits came from the FCC filings for each of the relevant constellations, as well as there's a paper, I don't remember the full name, but it's a technical overview of low Earth internet service providers. There's a link in the code example with all this, with a reference to that paper, so I referenced that as well.
Very cool.
So this guy's running. It went ahead and inserted 133 satellites in a few moments there. I don't have them turned on by default because I can already see them visually here. But then we can start doing stuff with this. So the first thing you might want to do is just do a basic compute access and go ahead and save that information somewhere. So we have this chain that I already have set up in SDK, and I'm just going to go ahead and add objects to it. Before I do, I'm going to just click this remove button to make sure there's nothing in there already. And then in this chain, I'm going to add AGI, the sensor, the field of view above AGI. And then I'm going to click add to chain. And that would be the same as going over here into the GUI and right-clicking and saying moving over objects in the list. But I just gave you the option to do it through this Constellation wizard as well. And then I'm also going to move over the SpaceX constellation. And one thing you'll notice is these constellations were actually already built, or they get built when you click load satellites. So all the children objects, so all the receivers get their own constellations, all the transmitters get their own constellations. So you have access to them real quickly, so you can go ahead and set up things like this chain analysis or coverage or further common analysis. So I click add to chain, I'll click compute. And once I do, you'll see a bunch of lines up here. These are all the satellites that you can see overhead, I think within a 45-degree cone angle above you.
Now you're saying C, but you're not putting a lighting constraint on them right now.
Yeah, there's no sort of lighting constraint. This is purely like RF comms. That's what I mean by C in this case. Although it's very easy for us to go through and throw in lighting constraints, as Josh said. And I know our EOIR expert is going to talk to you guys soon about seeing those those trains of satellites go through and how it might affect some of those optical telescopes.
Absolutely.
So here,
That's really cool.
Yeah, you can pull those in real quick. We have chains. Those a chain. We can see the access. I'm going to go ahead and turn that guy off. But another thing you can do very quickly is add in. I have SpaceX selected right over here. I can add it to my coverage, and then I can click compute coverage.
And everything you're showing us is we're representing it visually, but you can go report out those numbers very accurately and run the report so that you can ingest it into some other program or some other script to do even further analysis, right? So it doesn't stop with what Austin is just showing you on the screen there. That's really just the visual representation of it starting, and all those times in and out of view, what the link budget is, all that exportable and usable for anything you need it for.
Yeah, that's exactly right, Josh. That was the primary motivation for building this, is to go ahead and leverage all of SDK's capability and really just sort of automate that workflow. So this Constellation wizard, it will attach to an open scenario. So whatever you already have built out, it's just going to attach to it and pretty much automate that process for you. And again, there's a script version as well if you want to go down that route. So this coverage, I just have a basic coverage set up with a number of asset and in asset. And I color the grid by the number of assets available to all these dots over here. So you can see it went through and calculated pretty quickly. But I only computed that for a 5-minute time span because I only loaded in about 5 minutes worth of data. All right, so that's a coverage definition. I'm just going to uncheck that guy.
And you could do final resolution on that if you wanted to, right? Because we're just keeping it quick. So in the interest of time for the video, you can increase the resolution of that coverage grid quite a bit and use parallel computing to distribute the load to other computers if you had a really big problem.
Yep. Okay, so that is the main abilities of the Constellation Wizard. You also have these unload options, so I can unload all these satellites, these constellations, all those files it built, or all those objects imported. When it actually saves these constellations to files, and there's like a deck, like a satellite deck. It's just a bunch of TLEs is how this works. So if you have your own constellation and you save that to a file, TLE files, you can just use that as well for these constellations. But before we go ahead and close this guy down, I wanted to show you one other type of analysis, a COM interference analysis. That's been pretty popular recently. So I don't have the buttons for those in the Constellation Wizard.
We forgive you.
Yeah, thank you. Maybe future request. But if we go to the properties of this COM system that I have set up, I put the transmitter and receiver from earlier into Constellation objects, so it can work with a COM system. So I have a geo transmitter, a ground receiver, and now we have interference, and I'm going to move over the Starlink transmitters into the interference column. Then I'm going to click OK. I'm going to go to my COM system. I'm going to go ahead and compute it. And then we'll take a look at the carrier to noise ratio and how that gets affected by the presence of the Starlink constellation, at least this planned one. Right now, I'm using 13.5 gigahertz for the frequency, which is what I found in the paper I was referencing earlier. And then the communication link to the geo is at 13.6. And again, this one's just a little bit notional. The frequency really does matter on how much interference you're going to get, but we'll show you that. So once this COM system finished computing, you'll notice there's actually a red line right here. That indicates the most interference, the satellite with the most interference. And if I play this, what will happen is you'll see it jump at different times. And you can...
Primary offender.
Yeah, the primary offender. Yeah, the satellite with the most interference. So if I want to go take a look at a report for that guy, or rather a graph, I'm going to run this carrier to noise ratio graph again. And you notice that there's a bunch of dips. So there are two things plotted here. The first one, I'm just going to...
Make that a little bit bigger?
Yeah. We're going to make this guy a little bigger and zoom in. Awesome. So originally, if I remember correctly, we had about 10.9 for our dB. But then as soon as one of these Starlink satellites flies overhead, you'll see your communication link sort of drop out. So I'm going to zoom back out on this guy, and you'll notice it goes from about 10.9 for the carrier to noise ratio down to negative 20 or negative 25. So if I wanted to take a look at this, I can right-click, and I can do a set animation time. And I'm also just going to show you that line to show you there. So we're near the bottom right over here in our signal. So if I go back to our 3D graphics window, you'll see that there is a Starlink satellite overhead, nearly overhead, almost directly over AGI whenever that link drops out. If you go and change the frequency of the communication, so you communicate at different frequencies, the dropout's not nearly as bad. It's almost non-existent. But depending on what frequencies, if you're near the frequencies that Starlink or these other large constellations are going to be using, you may experience some dropout.
When you start doing longer analysis, you mentioned it earlier about sticking a loop into your code. Can you bring that up for a second? We can just sort of bring up your code, and we'll just show them just real quick what Austin was talking about. And also, we are using desktop SDK with this, and we talked earlier that you could use this with a headless engine. So if you used headless SDK engine, you wouldn't have the UI the overhead of that. And so you could add thousands and more things and still be performant in getting your reports and graphs out. You just wouldn't be able to see it until later.
Yep. So we have a code example posted right now, and in that, all these files are going to be included. We have the Constellation Wizard, the UI, the user interface. That's what I was just showing. We have this Constellation Wizard notebook, which is a Jupyter notebook. And the way that works is you basically execute chunks at a time. But it's very easy to just do a file, download as, and you can download it as a .py file, so you can just run it, the whole file, write it once, put that into a for loop, connect to engine instead of STK.
Yeah, they got that part right there at the bottom.
And then
Scroll down a little bit.
then you're in business.
Yeah, so that's the part you would switch who you connect to, right?
Yep, that's exactly right. There's a function, there's a couple helper functions. Instead of connecting to STK, you just connect to STKX or STK engine, and it would probably get a couple times performance boost there.
Very cool. And so people who don't have access to the large amounts of planned data satellites, you could help them with your script to load the data if they did have it using this interface.
Yep.
So now you know how to go to CelesTrak, get the latest data. You can use Austin's script here if you want to pull in the data right into SDK and then start doing some of the analysis. And if you have any questions, like always, there's tons of content on agi.com of getting up to speed with the tutorials, and there's constantly training. So if we were here talking in SDKEs and we said something that you didn't understand, there's plenty of resources for you. Hit up AGI support if you have any questions. And Austin, thanks for showing this. This is a really cool thing. I think this is a start. I'm sure we're not going to be done talking about these constellations yet. There's a lot more ground to cover on the type of analysis that we're going to do and see. And it's an exciting time, an exciting future.
Yep. Like it or not, they're coming in there.
Yeah,
Here
that's
to
right.
stay.
Our RF comms expert has said before in the past, it's not a matter of if you're going to get interference from these large constellations, it's a matter of when. And then we don't say that for negative purposes. We think that this is great, that there's going to be this many satellites. It's just we're all going to have to plan a little bit more, and that's the new world. That's how it's going to be. But this is really cool. So hit us up if you have any questions, and we'll provide the links below down in the description if you want to get some of this stuff. All right, thanks, Austin.
Thanks for watching, guys.